Welcome to Formula 1 Maths. This is sample exam questions 005 for the AQA Level 2 Further Maths course. We've got 3 questions to answer. Question 1. Y is equal to 3x to the power 8 minus 5 over x squared. Work out dy dx. So for this question, we need to rewrite this term in a different form that will enable us to differentiate. So 5 over x squared can be written as 5x to the power minus 2. So the whole expression becomes y is equal to 3x to the power 8 minus 5x to the power minus 2. For the first term, 3x to the power 8 dy dx will be equal to 8 times 3, which is 24. Then we will reduce the power of the x by 1. So you're going to get x to the power 7. Similarly, for the second term, this one, which is minus 5x to the power minus 2, dy dx will be equals to minus 2 times minus 5, which will be 10. Then we reduce the power of x by 1, and we get x to the power minus 3. So the whole differentiation becomes positive. This one is positive because negative 2 times negative 5 is positive. We can rewrite this as 10 over x cubed. And so we end up with dy dx is equal to 24x to the power 7 plus 10 over x cubed. And that is question 1. Question 2. In the expansion of a plus 2x all raised to the power 6, the coefficient of the term containing x to the power 4 is 15. Work out the possible values of a. So for this one, we need to raise 2x to the power 4. That implies that the a must be raised to the power 2, because 4 plus 2 must give you 6 over here. So now we are left with the binomial coefficient of that term. This can be 6c4 because of the 4 here. It can also be 6c2. So this implies that 6c2 is also equal to 6c4. But this is a non-calculator paper. It's easier to calculate 6c2 without a calculator than 6c4. So how do you calculate 6c2 without a calculator? We start doing 6 factorial and we stop at the term 2 because of this 2 here. So that would be 6 times 5. We stop here because of the 2 here. And then we divide that by 2 factorial, which is 2 times 1. We can reduce this by saying 2 goes here 1 and 2 goes here 3. And that gives us 15. If we chose to do 6c4 without a calculator, then we do 6 factorial and stop at the 4th term, like this. We stop here because of the 4. And then divide that by 4 factorial. And as you can see, this 4 cancels with that, and this 3 cancels with that. And then we are left with the same thing that we had here, 6 times 5 over 2 times 1, which is here. And so we get the same answer as 15. But like I pointed out, it's easier and you save time by calculating c2. So now that we've got that, we can go and write our full term as follows. So 2 to the power 4, which is what we got there. And then our binomial coefficient for this term will be 64. And the a will be raised to the power 2. But 64 is the same as 62. So that will be 62 times 16, because 2 to the power 4 is 16. Then a squared is a squared. And then x to the power 4 is x to the power 4 here. As we've seen already, 62 is 15. So we end up with this. 15 times 16 times a squared times x to the power 4. Simplify that, and you get 240 a squared times x to the power 4. But we are told that the coefficient of the term containing x to the power 4 is 15. And the coefficient of this term is this here. And that's the coefficient of the x to the power 4. And this is the one that will be equal to 15 as follows. And then we rearrange to get a squared is equal to 15 over 240. If I reduce that, I get 1 over 16. But we want a. So we have to find the square root of that and the square root of this. And if we do that, we get a is equal to square root of 1 over 16. And square root of 1 over 16 is plus or minus 1 over 4. And these are the two values required. Question 3. F of x is equal to 8x over 3, all of that raised to the power minus 1. And g of x is equal to square root of 1 minus q to the power 5, where q is a constant. Given that f of 0.5 is equal to g of 0.5, work out the value of q. So first of all, we find f of 0.5 and g of 0.5. So let's find f of 0.5 first, and that means substituting half or 0.5 into x. So that will be 8 over 3, which is here, times x, which in this case is 1 over 2. All of that raised to the power minus 1. Then I can reduce this fraction. 2 goes to 1, 2 goes to 4. So I'm left with 4 over 3 raised to the power minus 1. But from the laws of indices, a to the power minus 1 is the same as 1 over a to the power 1. That means 4 over 3 raised to the power minus 1 is equal to 1 over 4 over 3, which is equal to 3 over 4. So this will give us 3 over 4. Now let's find g of 0.5. That means substituting 0.5, which is half, into x. So that's square root of 1, then a q. Then instead of the x, we put 0.5 and raise it to the power 5. Now, 1 over 2 raised to the power 5 is the same as 1 to the power 5 over 2 to the power 5. But 1 to the power 5 is 1, and 2 to the power 5 is 32. So this will become 1 minus q over 32. All of that raised to the power half, because the square root is the same as raising the whole thing to the power a half. Now we are told that these two are equal. So I'm going to equate this one to this. And so we get 1 minus q over 32 all to the power half is equal to 3 over 2. To get q, we need to square both sides of this equation. If I do that, I'm left with 1 minus q over 32 on this side, and then 3 squared over 4 squared on that side. This will give us 1 minus q over 32 is equal to 9 over 16. Rearranging will give us q over 32 is equal to 1 minus 9 over 16. That means q over 32 is equal to 7 over 16, because 1 minus 9 over 16 is 7 over 16. Then we can solve that to get this, and then we can reduce this here. 1 is equal to 2, and that means Q is equal to 14. And that is question 3. And this brings us to the end of this set of questions on SEQ 005.